Well, you've also co-authored with Ron Kennett, Information Quality, the Potential of Data and Analytics to Generate Knowledge. And I should let our viewers know that we're very excited about featuring you and Ron as two of our keynotes at the upcoming Discovery Summit in Prague in March of 2017, and that the two of you will conduct a joint book signing. So that's going to be great. But why don't you tell us more about information quality, because it's a very, very broad concept and very useful and a very structured way of thinking about things that I think people should really take a look at.
That's kind of an interesting concept, and I think that it's not the traditional thing that statisticians do. InfoQ was born, I'd say, about 10 years ago when Ron asked my feedback on a piece he was writing for a Six Sigma Forum magazine. And the piece he was writing was called something like From Data to Information and Knowledge. And at the time, I was already teaching the course that I was just telling you about at University of Maryland, where my students were working on real projects. They were getting real data and trying to solve real problems. And I noticed that there was some recurring problem, if you want, that students would start working on a problem, they would gather data, and at the end of the day, some of the teams weren't able to answer the question they were trying to ask with the data that they actually collected. So when Ron sent me that piece, I looked at it and I said, you know, one thing is bothering me here is that we don't even know if the data contains the information that's needed there. And it was just a vague feeling, and it was very raw at the time. And Ron right away picked up on what we were talking about. And this very quickly rolled between us multiple times into formulating what exactly is going on. And we wrote the paper, and the paper went through, wow, quite a cycle of what papers go through, especially when they're unusual. And in the end, it ended up being published in JRSS with some very interesting discussions. But the fundamental part there is a question that's fundamental to anybody who does statistics or data analysis of any type. And that is, does the data set that you have right now, or that you're going to be investing in getting, does it have the potential to answer the question that you have, given that you're going to use data analysis? So the extra piece here is that you're going to be using data analysis. And that makes it very different from, say, data quality. Data quality, the data lives on its own.
Right.
There's no goal. There's no data analysis.
There might be multiple uses.
There might be different uses. And data quality is a huge field.
Right.
Enormous. I mean, in so many areas. But nobody talks about putting it together with the analysis. So what we did in InfoQ was we said, first of all, there are four components going on here. There's the goal that you have to consider. There's the data, of course, specific data set that you're looking at. Then you have the analysis that you're going to be using, or a set of methods that you're going to be using. And of course, you don't use every possible thing under the sun. Right. And an analyst has a few different methods. And finally, you have the utility, which is, what are you going to get out of this? And when you consider all these four things together, there are a lot of things in the combination of the four that will help you determine whether there is enough InfoQ in this data set or not. Then the next tricky part is, once you define some abstraction like InfoQ, what is this InfoQ? How do you touch it? How do you measure it? You have to come up with a way to measure it. And that's where we devise these 8 dimensions. So a very classic way is, when you have such an abstraction, is to break it down into dimensions that are more measurable. And we broke it down into 8 dimensions. And these InfoQ dimensions are things like the data resolution. It could be a temporal resolution. It could be a geographical resolution. It could be the level of aggregation of the data. All these different aspects that you're going to ask yourself questions about. Then you have another dimension, which is things like data structure. What kind of data is this? Is this cross-sectional? Is it a time series? Is it text data? Is it what exactly do you have here? Other dimensions have to do with temporal relevance. What's the relationship between the goal and the time you collect the data and the analysis, and when you're going to be deploying it? Because different scenarios have completely different chronologies and different temporal
shelf
sequences.
lives, and yes.
Exactly. So a data set might be very valuable in this study, but because the whole chronology is different in a different study, it's useless there.
Right.
So there's these 8 dimensions that we built, where you'd basically go and ask all these questions about your data and about your study and rank them. And based on the ranking, you'd get some idea of how valuable the data is. We later expanded this. You can also evaluate not just a data set, you can evaluate a study. using the InfoQ.
Right.
You can do it for studies that happened already, or you could do it for proposals. Let's say you're going to write a proposal for a study. So it's a very useful framework that we think is extremely important to put on the table, because everybody's doing this indirectly this way or that way, but no one's talking about it or teaching it.
Right, or having a methodic approach to it that you can make consistent, and actually talk about that information quality is multidimensional. So how can you kind of get a sense of overall what it is?
Exactly. And you know, the interesting part is when I present this, and Ron has presented this extensively in lots of places, I've also presented this in several different audiences, and the people who are most excited about InfoQ are the empirical researchers who are not necessarily statisticians even, because they face these problems all the time.
Right.
And when I give those talks, it gets so engaging that you right away realize this was something that is really missing in the toolkit. So InfoQ, I think, is going to be very important. And the book has an interesting combination of a part that just explains InfoQ and the methodology and measurement and everything. That's part one. Part two looks at InfoQ in a bunch of different areas. So we took different fields like healthcare and education, and we gave examples of studies and how you would analyze them with InfoQ to give people in different areas an idea of how to use it. The third part is about using software, and that's where we also have the JMP add-in that Ian Cox wrote a chapter about. And that's a wonderful addition to show how the software can really help the researcher learn more about their study or about their data set.
Well, I'm really glad you brought that up, because while static text and graphs in a book are limited in what they can convey, we thought it would be useful for our viewers to see kind of the dynamic, interactive nature that is JMP. And as you mentioned, Dr. Ian Cox, our colleague at JMP, he's kindly prepared a short demo of evaluating information quality of a water quality study and how JMP supports information quality via this add-in. And he also writes about the same example in chapter 16 of the book. So I thought it would be good for our viewers if we take a look.
Great.
This brief video shows an InfoQ assessment of a JMP analysis. Reliable assessment of water quality is important for many ecological and economic reasons. Traditionally, water samples are taken in remote locations and subject to laboratory testing, but this takes time and money and is difficult to do on a large scale. The practical goal of this analysis is to avoid the need to take such samples, relying instead on land features extracted from satellite imagery to make predictions of aquatic properties. In this example, there are 4 responses, or Ys, and 26 possible predictors, or X's. Given we expect correlations between these variables, partial least squares, PLS for short, is a reasonable way to try to build the predictive model we need. This shows where the water samples were actually taken, from 2 different states and 3 different ecoregions. This shows that some of the data rows are incomplete due to unmeasured values, and this affects the details of the analysis. An important consideration is whether we should have one overall predictive model or a separate model for each ecoregion. This helps us to address this question. As expected, the X's are highly correlated. Similarly, the Ys. This launches JMP's Fit Model platform to start the PLS analysis. JMP automatically recommends we use 2 latent variables or factors. The VIP versus coefficients plot allows us to assess contributions to both dimensionality reduction and regression, and can be used interactively to produce a parsimonious model. Holding back some test data to check model performance is an important part of predictive modeling. We can simply add prediction columns and look at predicted versus actual values of Ys for the test data, or for all of the data by manipulating JMP's row states. Now the PLS analysis is complete, we return to our synopsis and move on to the InfoQ assessment of what we've done, using each of the 8 dimensions. Note, for instance, that chronology of data and goal is scored as low, Part of the reason is that acquiring up-to-date satellite images is presumably not under the control of the analyst. Taking the arguments presented here on trust, the InfoQ score is calculated as 0.58. But, insofar as the scoring is subjective, it's useful to allow a range of values for each dimension. A simple jump add-in supports this, resulting in an InfoQ score in the range 0 to 0.69.